Hello, my name is Michael. Welcome back to Mazdoko Block, episode 18. We are going to solve puzzle size by 5, difficulty 1 without operators. First, we start with single cells. I found this one. Okay, let's look in cage B3. What can form 3 from the numbers at the left? We have number wise 2, 3, 4, 5, and 3 can be formed from all of that is just 2 and 5. And then rest of the column is gonna be 3, 4. Now let's look in row 1 and what let's write down the candidates for values 3 and 4. Number 3 can be formed from 1, 2, 1, 3, 1, 4, 1, and 2, 5. 4 can be 1, 3, 1, 4, and 1, 5. As you see from option for 3, that's mean that for any possible operators, that's all possible combinations. But you see that 4 has all of the candidates for 4 required to have number 1, meaning that for value 3 in this case, all of these options with number 1 not feasible, so it's only 2 and 5. And for 4 we have not unique combination, we can have 1, 3 or 1, 4. 5 cannot be because it's already taken in this cage. Alright, let's go to the next next cage. It's this one. How can we get number 7? Number 7 can be 2, 5 or 3, 4. However, it cannot be 2, 5 because we already have 2, 5 in this cell. So we can't have both of them in this case, so it has to be another option, which is 3, 4. Alright, let's look in this cage. What number are left? If we know 3, 4 are taken here, it will be numbers 1 to 5. However, none of the numbers with 2 would work. 1, 2 doesn't make 5 with any operation. 2, 5 doesn't make any 5 with any operations. So 2 cannot be in this cage, so it has to be here. If 2 is here, then we know that 5 is here. Now if we look in cage D4, what are our options? As we discussed, it can be 2, 5 or 3, 4. If we assume it's 3, 4, we have 3, 4 here and 1, 3, 4 in this cell, meaning that for these two, only options left are 2, 5. But 2, 5 don't form a value 2 with any operations. So, meaning that 3, 4 cannot be our candidate. So, our candidates are 2, 5. And if they're 2, 5, then what operations can be left here? From 1, 3, 4, only 1, 3 make 2, and therefore there has to be 4 here. Now we can see we got single cells, single value cells, so we're gonna be chaining 1 by 1. We got 3, now we have these 2 to eliminate. Okay. Now let's look in row 2. We have we're missing number 2, so number 2 has to be in this cage. What operations with number 2 can get 6? It can be 2 multiplied by 3 or 2 plus 4. We can't use 4 because it was already here, so we know that it's going to be 2, 3 in this cage. We can eliminate 3 from this cell. We can keep eliminating. Okay. Let's look in row 4. we have what options we have here. We have numbers. Number one should be somewhere here. If number one in a cell which is value 1 means the operation is always difference, so the other number will be necessarily 2. So one of these two cells are 2, meaning that it can be 2 here, so we can eliminate 2, we can eliminate. Okay, row 5, we have number 1, 2, we have 3, so some number 5 has to be somewhere here. It can be in this column, so it has to be here. If it's 5 here, then it's 4 here. Now we got another things to eliminate. Okay, let's look in the column B. We have options for here are 1, 2, 3. And the number 1 can be formed as 2 minus 1 or 3 minus 2. However, if it's gonna be 3 minus 3, 2, it's not possible because for this cell we have no more options. So it can be 3, 2, so it's gonna be 2, 1, and then we eliminated 2 from here, so it's gonna be 3, eliminate from here. Okay, and now we have the only missing values in each row which we fill. Okay, that was a little bit more challenging than usual, because the more we have no operators, more options we have, it's gonna be more challenging but more interesting. Stay tuned for more episodes.